This time we'll practice for the quantitative qualitative transition problem for AP Physics 2, and I will use the number 2 question from the free response question on 2019. So if you don't have it, you can download it from the link below this video, or you can directly download it from the College Board website. Do you still remember those strategies that I mentioned for this quantitative qualitative transition problem? If you don't understand what I'm talking about, then you have to go the first video lecture for this series and watch that video first before watching this one. And yes, you have to read an entire question at first, thoroughly but quickly. And during that time, you need to collect all the important information and the core words from there. And the strategy 3 is important. You better finish the quantitative analysis part first, because once you have a mathematical expression for that, it's easy to understand the qualitative analysis part and easy to make a statement for that. So now, just to make a little pause for this video and read whole question number 2 on the 2019 free response question package thoroughly and quickly, and try to find out all the important information from there. Okay, did you figure out what was the important one? Okay, so the pattern, yes, question A was a qualitative analysis, and question B was a quantitative analysis, and C was connecting this A and B together, and D and E is just the following short answers. These are interesting, right? I explained similar things on the AP Physics 1 practice question 2. Although the College Board announced that you guys have 2 format of question only in this year, which are the qualitative quantitative transition and the paragraph argument question, but like this, you will have these kind of short answer problem after that. So you should prepare to answer those kind of short answer question as well, not only just only focus on the QQT format and the paragraph length argument format only. Okay. Let's start with strategy 1 and 2 first. So what are the important information from there that you found? I found ohmic resistor and negligible resistance and significant internal resistance are for circuit 1 and circuit 2. Why they are important information to us? Ohmic resistor, that means we can use Ohm's law V equal IR, and we can treat R as a constant. Okay, so our V equal IR, that graph will be linear relation with each other. And this one is about the comparison between circuit 1 and circuit 2. So of course, the most important thing for there is the difference between 2 circuits. So what are the difference here? So circuit 1 has external resistance R only, and circuit 2 has additional internal resistance small r as well. That's the key point of these 2 circuits. Now, what is the important thing for A and B here? Okay, did you find out? Whenever you have anything related to the graph, the most important thing is what is the value here. Okay, what is the independent value and dependent value for that graph with their unit as well. Okay, so you have to check what kind of value over here. I have current and potential difference here. If you study a lot about this kind of the graph for the Ohm's law, you have to catch, usually the graph for the Ohm's law was a V over R. So V versus I, that's V versus I, yeah? Ohm's law, VIR. So when you make a graph V versus I, the slope will be related to the directly proportional to the resistance value. But here we have upside down. Okay, so you should keep in mind that one. There's a little bit difference here. And second thing is about we need to write down expression, the equation that satisfies conservation of energy in terms of delta VPS, I, R, and small r for the internal resistance of it. So this is the thing that we need to write down, and in terms of these variables. Okay, so you need to using these notations to express this conservation of energy for the circuit. That's the key point things that we need to find out. Okay, so if you know if you clearly know what you have to write down, then we can find out the answer easily. Like I explained on the strategy number 3, we'll start from quantitative analysis part first. From here, we can get the very important mathematical expression, and based on the mathematical expression, we can make the statement for the qualitative part easier. What is the question for B? We need to find the equation for conservation of energy here. What is the conservation of energy? What is the equation satisfy the conservation energy on the circuit? Do you remember that? That should be Kirchhoff's loop rules. Okay, so Kirchhoff has 2 rules. One junction rule about the current, and the loop rule is about the conservation of energy. What is Kirchhoff's loop rule? Okay, around this closed circuit, the difference of the potential change will be always equal to 0. That's the Kirchhoff rules, right? So around the circuit, we have to have delta V sum must be equal to 0. This is the Kirchhoff's loop rule. Okay, so here we can start from the voltage. Delta VPS is a gaining voltage in this circuit, and consumed IR equals 0. This is just as simple the equation satisfying conservation of energy in this circuit 1. And this circuit 2 is delta VPS minus IR. This is the voltage drop across the internal resistance here, and minus IR is a voltage drop across this external resistance R value equals 0. You may just simplify, factor I out this one, but this one is also okay. Okay, these are the answer for B. Easy. Okay, so once you recognize the conservation of energy of the circuit is talking about the Kirchhoff's loop rule, then you can find out answer easily. Okay, and these are the mathematical expression that we need to write down for question B. Now, time to go back to the question A for qualitative analysis part. This becomes very easy because we already have this mathematical expression. See it? Okay, so we need to sketch the graph. We need to plot the graph, current versus the power supply potential difference. Here, the current is I, and potential difference is the delta PVS for here. So that means we need to find out the relation between I versus V, delta VPS. Okay, so here we need to isolate I. So these are the equation that we found from the question B from the previous slide. And here, and our I, we have to isolate the I because we have dependent variable as I. So that is 1 over R delta VPS. That's what I found. And here I is equal to 1 over R plus R delta P VPS. That's what I found. Okay, so whenever you have I something delta VPS, the same as Y equal KX linear relationship, and whatever you have inside here is slope. So now I have slope 1 over R for circuit 1 and 1 over R plus R for circuit 2. Now it's very easy. So now already we found out this is the linear relationship, so we have to draw the straight line only passing through the origin. And this one's slope is 1 over R, this one is 1 over R plus R. We have additional small r on R, so this R plus R, total resistance for the circuit 2 is greater than total resistance of circuit 1. And their slope are reciprocal. So since this total resistance is greater, slope for circuit 2 should be less. And circuit 1, slope of circuit 1 should be steeper than the circuit too. So we can draw the line to line passing through the origin like 1, 2, and don't forget the labeling. This is 1 and 2. Okay, that simple graph is the answer for question A. Okay, since we found out the mathematical expression first, it's very easy to draw the graph to finish the answer for qualitative analysis part. Now, we need to connect A and B, but it becomes so easy, right? We already explained everything. I already explained everything in the previous slide because we build mathematical expression first, and based on the mathematical expression, when we draw the graph, we already draw the graph using the mathematical expression. So we already know the relation. Okay, I already explained about the slope and the reciprocal resistance value, these kind of things. We just need to write down and summarizing the explanation for the A and B. Okay. By the way, if you need to find out the relation with the equation or the situation with the graph, then the thing that you have to mention is usually about the slope or y-intercept or x-intercept or area. These kind of values is important from the graph. So depending on what kind of question you have to find out which one is actually related to the slope of graph or area of the graph or the y value, x value, these kind of things that you should find out. Okay, so back to our question. What was your answer for C? Here is my example. Okay, the current and the potential difference has a linear relation with each other, and the slope is equal to the reciprocal or inverse of the total resistance as shown in the equation above in the question B. The graphs are linear in question A, and one with a smaller resistance, circuit 1, has a greater slope of the graph in the part A, and it is supported by the equations in part B. So we clearly link two concept A, the quantitative and qualitative, properly. So that could be one of the proper answer for that. Okay. Yes. I hope this video was helpful for you guys to understand the quantitative qualitative transition problem for the AP Physics 2. You can get some idea how to approach and how to write down your answer for that kind of format of question. Okay, I will make another video for the paragraph argument question for AP Physics 2. So you better watch that video too. I will upload it soon. Okay, if you have any question about this lecture or any question about the AP Physics 2, email me. I will do my best to help you guys. Okay, thank you and good luck for your exam.